Welcome back. Okay, moving forward. This one was an easy one. Next week, a new one, but now about the content, not about, easy questions from the syllabus. So moving forward, we have been talking about requirements so far, two scenarios. Number one, the Pac-Man video game. Number two, I asked you to review this final project for 360, most about information handling. By now, you know, customer idea, like me talking in the video, customer idea, like asking you for the Pac-Man. Those ideas are what I want, my necessities, my needs, my specification maybe, but they are not requirements. In order to create requirements, we did this exercise, previous lecture, about what is a real requirement. The goal, you have something here, down, you have the steps, the instructions properly. Your requirements are in some point in the middle, not too small, not too big. You need to move and found this place. What are those things that follow the criteria of invest, independency, negotiable, can be tested, they are small, etc., and those conform your requirements. For your requirements, you can put them in a document, text, this idea of the user stories if you're going to move to Agile, or you can take advantage of UML, particularly the diagrams, and something that is clear now is every single oval in a use case diagram corresponds to a user story. Every single oval, every single user story is one requirement. The collection of ovals, the collection of user stories, they are all the requirements for your system. I am talking about the requirements, the functional ones. You do not create them in a line. You do not start writing user stories or requirements used from here down. It's an iterative process. You start with ideas, brainstorming. For the Pac-Man, we reviewed this. We start with identification of actors and some ideas about what should happen, and talking with the team, reviewing things, split things. Suddenly you create something that looks more like this. All of this, the requirement for the Pac-Man, something that we review later is a good idea to identify the connection between the requirements. Connections, we review, I give you a full quick review of your 360 knowledge, in particular, which are the relationships that you can use between requirements. And previous lecture, we talk about inheritance, inclusion, extension. Key ideas is which of these requirements are fundamentals, which of these requirements are important because they are inside of another, or which of these ones are just optional things. And those are things that we represent with these arrows and these roles there. Previous lecture, hopefully that is clear. Now, we are here. We have finally our requirements. We have finally this idea of what the software is going to do and how these requirements are connected, how they interact. Your question right now, and something that in the previous lecture we stopped, is, good, I have the requirements, but there are a lot of information that are details that I didn't put here because, well, we were moving from the big idea to the details, and we were here, but there are a lot of things here, a lot of details that basically I ask you to do not put here. What I do with that? Previous class, and I am going to start with this, is the details. The details go to the activity diagram and the state diagram. And I am mentioning the names because they are two diagrams that you review in the 360 class. Don't worry, I am going to make a parenthesis to talk about them. But again, you have your use cases, your diagram, the big picture, this one. And when you need details for something, the way to add details is using activity diagrams and state diagrams. For instance, I am sure that you are thinking, these guys here, the movement of the enemies, the movement of the ghosts, they need more information. I put 4 requirements there because I know that they move in a different way. If I want to ask you to implement this, there you need more information. What are the specific for the movement of those guys? If we're talking about collision, and in particular we're talking about this, who is going to die? The Pac-Man or the ghost? These two need more details, more information that is not here. That information, activities and states, particularly. When you need more information, you need to think about, okay, the extra information that I need is steps, activities, conditions, or loops. The extra information that you have in your mind is about specifying something that is going to be done again and again, or something that is about a condition, one thing that will happen or another, or is an instruction. Those 3 things, instructions, conditions, loops, the movement of the Pac-Man, the ghost. I can give you the details. They are on the internet. And you can get the particular movement for one, the other, the red, the pink, the blue, the orange. The information is there. The point is, this information is all about conditions and loops. It's all about go and check the X and Y of the Pac-Man, check the X and Y of the ghost, one of these. And with those values, do something. Do something, they are close, they are far away. Where is the other ghost? Some of these work in teams. Compare the numbers, condition, and take a path, make a decision. These particularities, and I am going to use the picture, all these are decisions, are ifs, details. They can be represented in an activity diagram. And that activity diagram is extra information for one of the requirements. If you are working with Agile, the requirement is this car with what do you need to do? And in the back, you can provide the extra information. The extra information, like one of these paragraphs, or you can go and move forward with a picture. Text or picture. Both options are available. Usually, pictures are better because they help you to understand the process. They help you to visualize the process and share that process with others. People do not read. If I give you this information like this, if I have look, you're going to read this. Maybe you are going to understand what is there. And I'm not talking about you students. I am talking about in general. People, 99% of the people prefer a picture. If you provide a paragraph versus if you provide a diagram, whatever it is, the diagram, the picture, the ovals, the squares, the arrows, they are going to catch the attention of the people. The letters, the words, usually don't. Again, it's not a rule, it's just things that happen with the human brain. Now, another option. What if the extra information is not about activities, it's not about something that is conditional or repetitive or instruction per se? The other option, and there are only those two, is the extra information is about data. It's about the value of a variable. It's about some variable that could have the value 1 or 2, red or white, whatever. The values of the variables, 1 or more, together, they are called a state. If you need to provide details about possible values, what you need is a state diagram. The full name, a state machine diagram, usually state diagrams. For the Pac-Man in particular, when we're talking about collisions between the Pac-Man and the ghost, between the enemy and the user, well, you could agree with me that the extra information that we need to have there is whether or not the state, the value of a particular variable is the Pac-Man eat the power pill and therefore the Pac-Man is the hunter, or the opposite. If the Pac-Man have not eat that particular pill, then the hunter is the ghost. And the result of the collision is going to be about that particular state, that particular value. Notice, I need to specify in an state machine diagram the possible values for that variable, the possible states for the Pac-Man or for the ghost. They are the same, use the opposite. And then in an activity diagram, in some place, there are going to be a condition in which the condition is going to say, well, there is a collision. Okay, which is the state? Hunter or hunted? And according with that, one or the other is going to die. So this is just an example. I am going to give you more. But my point is extra information of a requirement, actions, activities, which basically mean loops, conditions, or instructions, or data. And for the data, I need to specify all the possible values for that data. The values in terms of what they mean. In the programming, maybe hunter or hunted or dead is 1, 2, 3. The numbers are going to represent that. But here, what I want is to explain all the different possibilities. The state for the Pac-Man, the state for one of the actors. At this point, what I need to do is a parenthesis and be sure that all of you are aware of these two diagrams. Moreover, that I can ask you to do one of these diagrams for a particular requirement. So I need to be sure that you can create the use case, identify the requirements, but also provide me with the details using the diagrams. Let's see. Parentheses. Parentheses, I am talking, this is 360. This is something that you know. So let's see. Number one, we start with the problem. We have the use case or user stories. We are here. We are trying to explain the details. Always, you can explain the details with text. You can explain the details with draws. I already mentioned this. Draws are clear to understand, and that is the reason because you review draws, the diagrams in 360, and I am going to continue with that idea here. So every single diagram that I am going to show, activity or state, they correspond to extra information for one of these ovals. And that is something very, very important to understand. Each activity or state diagram is extra information for one oval, for one requirement. They cannot live separate. The big picture, the index, is this use case. And then for each of the ovals, you can go in deep detail with one or more of the other diagrams. So we're kind of inside. The diagrams, the others, just to give you the picture, something that you review previously, UML, a modeling language. When you listen UML, diagrams, a lot of different categories of diagrams. In particular, there are two kinds of diagrams in UML. Diagrams to show the behavior of something, the behavior of the problem. Diagrams to show the structure of the solution. Behavior of the problem, the structure for a proposed solution. Something that we're going to review later is the class diagrams. You know them, we're going to use them a lot for the proposed solution later. Right now, trying to understand the problem, we use the use case diagrams. A brother of the use case diagram is the activity, and another brother, the state diagram. The last one in the family is a set of interaction diagram, including this one that you already know, the sequence diagram, but right now we do not need them. So the family of behavioral diagrams, behavioral draws for the analysis, we're going to deal with use case, activity, and state. As I mentioned before, this is kind of the big brother, the first one, the important one. The other two are going to help this one with the details. The activity with the details about the process, the state with the details about values for variables, global variables. Well, they are going to be globals later. Good, so fine. Some slides with information that you can review later, but I need to move forward with the practice. Let's start with the activity, the most complete. Activity diagrams. Before starting, can you tell me what is an activity and moreover, the difference of activity and requirement? And I am asking this in the slide because it's going to be in your exam. What is an activity and what is the difference between activity and requirement? Anyway. What is an activity? It's the same to the requirement? I like that. Activity, steps, actions, in particular, conditions, loop, instruction. That is what we call activities, all of that. Action to be taken, yes, thank you. So that is the same as the requirement? Yes or no? For the exam, true or false? Question in your next quiz. Activity equal to requirement, true or false? False, thank you. At least 2 and 3, okay, good. Why is false? It's not the same. And hopefully you agree with me, no, it's not the same. Requirements are here. We have been working a lot to put the requirements there. And we have been mentioning a lot that the steps, therefore the activities, are something down, the details. Makes sense? It's again, the activity, the detail, the specific things that are going to happen in order to accomplish the requirement. The requirement is a service, a functionality, something that the software is going to do. The details about how to achieve that to happen, the activities. If you want to make a comparison with programming, when I talk about activities, I am talking about instructions, statements, expressions. When I talk about requirements, I am talking about methods or classes. And you can make the picture. The statements, the instructions, the expressions, they go inside of the functions or inside of classes. One are small, the others are big. Activities, requirements. Moving forward, as I mentioned before, sequence, condition loops, and something that is in the diagrams that maybe you haven't used yet is things that could happen in parallel. I am talking about what in programming is going to be threads, multi-threading. You can have a program and that program is going to be doing more than one thing at the same time. It's something that is going to happen later in programming, but in the requirements, we can specify things that could happen at the same time. And the diagrams help me to do that. Moreover, the actors, those actors that we have in the use cases also are going to be or can be in the activity. Think about this. Always, 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 if you have a requirement, an oval, that oval is connected with something else. And one of the options for that something else is to have one actor connected with the oval. So it makes sense that if I am going to provide details about this requirement, well, maybe I need to know about the actor. If I have only one, probably not. But what happens if I have two actors connected with the requirement for any reason? In the collision between the Pacman and the system, I have probably two actors involved, one moving the Pacman, one moving the ghost. In order to happen the collision, both or one of them move. So I have two actors there. I can represent the actors also in the activity diagrams. Mandatory? No, it's not mandatory because maybe the requirement is not connected with an actor. We have several examples of that. Or maybe it's connected only with one actor. So do not make sense to mention the actor because we know that it's only one. But in this scenario with more than one, probably could be a good idea to mention the actor. I am going to show you an example. So sequence, concurrent, condition loops, actors. The elements in the diagram. I give you the list, but I am going to move forward with the examples. Things that you can use in an activity diagram. If you look at diagram, and that diagram have rectangles, usually with the rounded corners, but well, rectangles, diamonds, bars, begin and end, the circles in black, and the lines that connect elements have arrows, normal arrows. We're not going to use any other, only that one. If you have that, you are looking an activity diagram. And one question in your quiz or in your exam is going to be, hey, this diagram, what do you think it is? Is an activity, an state, or a use case? Just like that. So be sure to remember kind of which one is what. Examples. If I have this diagram, it's not the full picture, but that one is a use case diagram. And I put a box because it's one page, it's one document. If I have that document, and I am telling you that a particular system have these two requirements, requirement one, checkout, requirement two, payment. Two requirements, and they are connected in some way that we explained already. But you know what? I need to provide more information about what is the meaning of checkout. I know that checkout is a requirement, but I need to tell you more. What is checkout? What should happen when I do checkout? The details are all about steps, instructions, things that should happen. Those details in an activity diagram. An activity diagram, the activity diagram for the requirement checkout. This diagram below is inside or correspond to the explanation for the oval with the red circle. All this picture and the red circle and so on is used for me to explain. It's not something that you need to put in the diagram, right? So elements in the activity diagram that hopefully you remember. 2. Black circle and black circle with another circle around. What is the meaning of this one? And what is the meaning of this one? Remember, black circle is start. Yeah, it's kind of obvious, right? The beginning, always, always, always. If you're doing an activity diagram, you should have one and only one starting point. One and only one end point. And everything that you create should be somehow connected from this point to this point. You cannot have anything lost. No dead ends. Now, what can you have? Rectangles, instructions, diamonds, conditions. Conditions. The conditions can be loops or ifs. What is going to be the difference? The arrows. If you want a loop, somehow you're going to create an arrow that connects back to some point. You can create a loop with the diamond. A loop is going to look like I am going down, but this condition maybe move me back to this instruction. And just with the diamond represents the condition. That one could be a while or a do while, whatever. I am moving down, but suddenly I have this condition, and if the condition is something, I am going to go back. If not, I continue. That is the representation of a loop. Or obviously a condition, and if you are going down, and suddenly here you have two options. Diamonds, conditions, diamond, if, or loop. Boxes, instructions. For this example, a checkout. You know what? A checkout is I am going to receive an order, and then here I have a condition. The condition could be this one, and I move there, or this one, and I move there. Two options. You can put in the arrows when you follow that arrows. What is the condition of the situation in which you are going to move in that direction? Or you can put the condition in the diamond, and the arrows could be yes, no, true, false. both options are okay. Usually the diamond is too small, so it's easy to put the text close to the arrows. In this example, non-mandatory. In this example, the payment is accepted, yes or no. If yes, one path. If not, the other path. If yes, complete the order and continue. These bars, parallel activities, in parallel, this one and this one should happen at the same time. That is what I am representing there. It's not one after the other, it's parallel. Threads, if I ask you for programming. After both of them happen, another condition. The other condition, and, oh, wait, this diamond, this line is the closing of that part. If the payment is rejected, I did this. If the payment is accepted, I did this. From diamond 1 to diamond 2 is an if else. Start of the condition, closing of the condition, start of the two paths, end of the two paths. And it doesn't matter if the condition was true or false. It doesn't matter if I send the order or not. The final action and the end of the activities. Each of the things that you put in the boxes, steps, things that are going to go to the programming as a method, details of one requirement. Do you remember your play a sound? Play a sound is going to be one of these boxes in one of the explanations. Compare the X and Y of something with the X and Y of something else for the collision. It's going to be one diamond in one diagram like this. Verify the status. The Pac-Man is the hunter or is being hunted. One of these diamonds. Easy. Now, similar ideas with other things. We reviewed this transaction in an ATM machine. I need to know more. It's like, okay, you want me to do software for a transaction in the ATM machine. That is a requirement. It's a functionality that the software should have. Tell me more about the details. Okay, details. A diagram that is kind of the inside of the software. From the beginning to the end. What should I do? Well, check for the access code, login, password, PIN, details. Correct or not? A condition, a diamond. Correct. Ask me for the amount. Incorrect. Something is going to happen with handling the error. Cancel the account. Give another chance. Whatever. Go back here, assuming that you solve the problem, or if not, just close the transaction. Maybe give another chance, fail for a second time, or you can add a third one. What happened? Details. Ask for the money in parallel, this and this. Both things happen at the same time. What? Printing your note and, well, somehow asking for the money itself. It could happen that the machine have the money. It could happen that the machine do not have the money. So other two conditions inside. In some point, I am done. I finish. I am not asking you to understand what's happened or how a transaction in the ATM is done. My point is all these elements in the rectangles, steps, details, never, you put something like verify a password or print something or ask for something in a novel. It's not a requirement. It's just a step to fulfill a responsibility. It's an activity, not a use case. Here and here, as you notice, this checkout have only one actor connected. These ATMs have only one actor connected. There is no need to show the actor in the diagram. It's just obvious. This starting point corresponds to this connection with the actor. The actor is the one that is going to start all this process. But when you have something like this, when you have a requirement and that requirement somehow involves several actors interacting there, the transaction in the ATM, well, we know that the customer is going to do something, what we describe here, but also we know that, well, the machine itself and maybe the bank is involved in the transaction. You can think about, well, I am going to ask for a particular amount of money, but that number is going to be validated by the bank if I have that number in my account. Or, as in the previous example, the machine is going to check that the machine have the money to give to me. So 3 different actors, the user, the system, 2 parts of the system. And something that you can do in an activity diagram, and I need you to remember this, is the actors become columns. If you have 3 actors and you want to represent the 3 columns. And in each column, you put the actions that are done by the particular actor. For instance, here, everything is going to start here, and the customer is the one that is going to start everything because he's going to do this. And after the customer do this, the next step is going to be that someone is going to verify that that data is correct. And the actor that is going to do that verification is this one. And it's going to be a condition. The verification is correct or not. If not, an action in this actor. If yes, an action in the user. Enter your PIN. Some of the paths could say this is end, final point. It is okay to draw this line down and connect with the only endpoint that we have, or put that circle there, another point. It's like the return in your methods. You can put one at the end and somehow make the condition to move there, or you can put several returns so you avoid waiting or drawing the line to the end. This obviously continue down. I split because the slides. So going down, you can notice activities in the customer, activities in the machine, activities for the bank. In some point, we end the explanation. Bars, rectangles, and diamonds. With those 3 things, you can explain any process, or that should be the idea. Anything, any problem, like the algorithm for the Pac-Man, should be able to be explained with this. Why? Because each of these later is going to become an element in your software. You can imagine which elements. Activities. If you use this software in 360, the Astah, the tool that helps you to draw the diagrams instead of PowerPoint or something else, you need to notice an activity diagram is going to be kind of inside of a use case. Because again, the goal of this is to explain one of the use cases. So you're going to notice this composition, and the same is going to be true for the state diagrams. So looks like easy, nothing hard here. Hopefully you remember state diagrams. These are easiest. Only 2 elements, only 2 things. States, boxes. Fancy boxes with the round corners, but boxes. And events, lines with a condition here, some text. Like the lines for the diamonds in the previous one, but here all the lines have a condition. And a line with a condition is called an event. All the lines in an state diagram are going to have some text, some condition, all of them. These diagrams represent values for variables. Always values. Where are those values? Here, inside of the boxes. The information inside of a box in a state machine diagram is a value for something. We do not know yet if it's going to be the value of an integer, a string, whatever. It's going to be a value. And what we are going to represent is the conditions that make values change from one to a different one. We are representing the global variables in the systems, maybe attributes in a class. Data, states are data. Examples. This one, if I show you this one in your quiz, what kind of diagram is this one? Thank you. Use case, right? Okay, again, this is a use case diagram. You have actors, you have ovals. And you know what? Here, this one. I have that use case there. And I want to explain more information about this requirement. I give you more about what is this teaching something. This is kind of the internal system in ASU. So I'm not going to go into the details, but include instructor teaching something. I need to give you details about the teaching. So for that particular requirement inside, I am going to give you this. Black circle, the beginning. Black circle with another circle, the end. Those two are the same as an activity. Yeah. Any activity or state diagram have a beginning and an end. Okay. Boxes. The boxes. Enrollment. Running. Final exams. The only thing is here in the boxes, I am not reading instructions. I am not reading something that is going to happen, like the boxes in the activity. What I am reading is values for a particular variable. Which variable? Maybe the variable is this class, CSE460. What is the status of the class? The enrollment is open for this class, or the class is currently running, or the class is in the final exams, or the class is closed. I am showing you here three possible values: enrollment, running, final exams. Could be more. The idea is the state diagram show you values, not actions. The values for the class, you can notice every single line. All these lines have some kind of text. The text is the condition, the situation that is going to allow go from one value to the other. For instance, in which moment CSE460 or any other class move from enrollment open to running, moving from here to here? Well, maybe a particular date, maybe a particular size for the class. That is the information that you put for the line. We do not have diamonds here. The condition is the line itself. Every single line have associated a condition. Moreover, there is no instructions here. It's one value and the condition to change that value to a different one. Maybe in a particular date, the value is going to change. Maybe because of a particular situation, the number of students, whatever, conditions. If you're thinking about the algorithm, for instance, which diagram do you use to represent the algorithm? And the answer is activity, state, or use case. Which diagram represents the algorithm here? Activity. Why? Because the activity are the steps. And an algorithm is basically the step to solve the problem. The algorithm is not in the use case. The algorithm is not in the states. This is your data. And the requirements is what we want. But the algorithms involved are the details for each of the functionalities, the activity ones. Good. So use ideas for your quizzes and exams, right? Okay. Just remember this. If I show you this, an easy mistake that some students do is this looks like the activity there. Wait, it cannot be an activity. It cannot be. One, these are not instructions. Two, in the activity, the only lines that have a text, if we go back, the only lines with some kind of text are those lines that go out from a diamond. The lines that are not in a diamond, all the others do not have text. If you identify a diagram and the diagram have text for everything, that is a state, no activity. And you need to read also the boxes. Those are values. You can create a diagram as complex as you want. For instance, this is easy, but you can be thinking like, well, for the enrollment, there is a lot of things that could happen during the enrollment. Sometimes this is something that is possible. Instead of having enrollment, and I want you to be aware that this box in red is this one here. And in some point, what I am doing is, well, 3 boxes, but then the first one is very complex. So the 3 boxes, but for the one that is complex, let's put it inside a hierarchical diagram. Yeah, the correct name is state machine diagram. Some people, including me, is just like, okay, state diagram. But it's state machine diagram, the full name. Yeah. So enrollment, I can take enrollment and say, well, wait, it's not only enrollment. Maybe for you is, okay, this class is open for enrollment, but the details are, in some point, the thing start, and CSE460 use a proposed class, and they add to the schedule, and they search for an instructor, and when they have the instructor, then they open for enrollment, but then you can enroll or not. So we are searching for, if the class is full, then we close the enrollment, or if the class do not have enough students, we close also. So here, more values for the state, more values for the state of the class. The class is use a proposal. The class is now ready to go to the schedule, waiting for a student to enroll. Okay, the class is open for enrollment. The class is full. Oh, it's full, but something can drop and go back to is open, and it's going to be there until something happens, and that something is, okay, this is closed, and this is closed, and we cancel, or this is closed, and we run the class. All the boxes, values. I didn't put here all the conditions. It could be a lot of information in my slide, but please, all these lines, all this should have a condition. And I think you can figure out which are the conditions, right? Again, some of them related with a particular date, some of them related with is a proposed. This one could be, do we have an instructor? Yes or no. Schedule. Today is the first day for you to enroll, move to open, and is full, whatever full means. 100 students, yes, no. 1 student drop, so that means that we can go back because there is a new place. Conditions. They should have conditions. Professor, your slide didn't have the condition. No, I didn't put the condition. I am asking you to think about the condition, but these lines should have conditions, always, in an state diagram. Good? Hopefully that is yes. Silence. Good. Okay, good. So that's it. Activity diagrams and state diagrams. 360. Close the parentheses. And well, now you are expert with activity, state, and use cases. I have a problem for you, and you can help me to solve. Just like with the Pac-Man, I would like to talk about a piece of software that I need. And step number 1, you can help me with the analysis And therefore, you can help me to create the diagrams, the requirements, and if you need it, the details. Very important thing, you do not create a state and activity diagrams for all the requirements. Just think about the Pac-Man. Some of the requirements for the Pac-Man need additional information, such as moving the ghost. But others, like drawing the Pac-Man, do not need extra information, not for variables, not for activities. So you use the activity and the state only when you need them. A new project, and I want help with the diagrams. There is this game, quotation marks game, and I am giving you the URL so you can play quotation marks. And the description for that game, that is more like a simulation, is as I put on the screen. It's not my description, the description of the author. The idea is the following. You have something like this, a grid. Yes, in the state diagram, yes. No diamonds in the state diagrams. The conditions are in the lines, yeah. So in this scenario, I have this simulator game in which you start with an empty grid and you can create entities. You can think about live entities, bacteria, people. Yeah, that one. And you can put them in any place. It's like I can put a guy here, and I can put another guy here, and another guy here, or here. I am drawing people, but really what you're going to do is use like fill one of those small places. So these dots, like the yellow one, represent these live entities. So the only thing that I can do in this scenario in the table is to click in one of the cells, and in the cell that I click, is going to turn yellow, and that yellow represents that I put an element there, an live element, kind of a human being there, or whatever you can visualize, like something that is alive. That's it. That is the only thing that I do. Just put people in the planet, and the planet is this grid. And the game is about these rules. The game, quotation mark, the simulation is all about checking the neighbors. The neighbors are, you know, if you have the grid, you can think like this is one element, and all the cells around are the neighbors of this person or this entity. And we have these rules, like if I do not have neighbors, if I am alone, I am going to die. Or if I have a lot of neighbors, like this is me, but I have a neighbor here, another neighbor here, and another neighbor here, and another neighbor there, or whatever. It's like a lot of people, I am going to die also. For empty spaces, if here at the center is empty, but around that empty space, you have 3 neighbors, like something was there, or there, and there. So 3 around me, something is going to happen, and you're going to have a new member there. So you get the idea of this playing with the life, like a simulation of life. You start with a population, and there are some rules that tell you that something is going to die, but also there are rules that tell you that a new element is going to be born. You start with a population, you run the simulation, and you're going to have generations. So things are going to move forward, and depending on the initial configuration, you're going to have a population that grows or a population that get lost, 0. These are the rules for the game. This is the explanation that you found in the web page. Moreover, you can go to the web page and play. You can put even only one or fill the things of yellow things and click start. And generation 1, generation 2, generation 3, generation 4. On the screen, you're going to have what is happening. The population is growing, where, or the population is decreasing. When you have the board gray color, everyone is dead. Use case diagram for that project. Can you do the use case diagram? For instance, this could be the question in your exam. Open question, use case diagram for what I just described. How many actors? How many ovals? Ideas. Actors, how many? How many and which are the names? Nope. Do we have a user? And it's like, yeah, someone is going to make click to put initial population, right? So yeah, we have a user. Do we have a system? Like in the Pac-Man was the enemy, the ghost, the system. Here we have a system. Yeah, I think so. Can you imagine in this idea of storyboarding that we need to think about what the user is going to do and also what the system is going to do? And according with my explanation, you can describe things. Yeah, that is a key idea. You have this start and something is happening alone, right? I mean, after I put the initial population in this thing and I press start, something is happening. And if something is happening, someone is doing that. Someone, who? The system, the computer, or whatever name you want to use here. That is a good point. And you notice that you have at least 2 actors. The user, well, just because I need to put an initial population, that is the only thing that the user is there. Can you imagine the ovals? What are the requirements for the user? What the user wants? What are the requirements for the system? What the system is going to do? Who is going to draw the grid? Who is going to put the number of the generation down? Do you remember the ideas with the Pac-Man? The maze. Now it's not a maze, it's a grid. Do you remember the idea with the Pac-Man? Moving the Pac-Man with the arrows. Now we are not moving anything. We are adding new entities. What else? Something else for the user? What about the system? What the system is going to do? Could you agree with me that one of the things, that the system is going to do is calculate a new generation? Can you agree with me that that is one of the requirements, maybe the most important requirements in this model? There are going to be other things related with things that are being drawn or even numbers that should appear, different things. Maybe one of the most important is this idea of the new generation. Do we need more details for the new generation thing? Because I show you all these rules. And maybe the main question here is, those rules, all this information here, should be in the use case diagram, or maybe in an activity diagram, or maybe in a state diagram. Rules, where they should be, how they should be represented. Calculate the neighbors, count the neighbors, all of that. They are activities or they are requirements. They are the what or the how. They are the details or they are the requirements. Yeah, agree with the chat. The rules. If you think about anything that is a rule, like this one, what we are describing here, what is described with the pictures and my talk, conditions. The element is going to die, yes or no. A new element is going to be created, yes or no. And there is a condition there. The condition, I need to count the neighbors. Counting the neighbors looks like one instruction. And if you want to put the details, it's a loop. Loops, conditions, activities. Activities for the details of one particular requirement. Calculate the next generation. What do you think the use case diagram of this game simulator is going to be bigger or smaller compared with the Pac-Man? The Pac-Man have more requirements or this guy have more requirements? Okay, less requirement of the Pac-Man. Just look the graphical user interface. I mean, just starting here and the possibilities of the things that I can do. Click, 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 start. The requirements cannot be equal. They are far less than the Pac-Man. And therefore, your use case diagram should be small. The use case diagram is showing me the requirements. Now, we have these rules. Well, in the Pac-Man, we have rules also. The rules for the movement of the different ghosts. The movement of the ghost, an activity diagram. These rules, activity diagrams. The only thing that we need to be sure is which of the requirements is connected, is the parent for that particular activity diagram. And well, it could be this one, or another one that you define here, connected with the system. Because the system is the one that is going to figure out what happened. What about state diagrams? Do we need to provide information about data? Any variable that is going to change from one particular value to another in some way? Yeah. Hopefully, you notice this. We need activities for the rules. Maybe a loop, because we need to explain that these calculations need to be done for each of the cells in the grid, and so on. Conditions regarding how the things are going to be handled. An approach that can help, that complement, is, well, let's think about the different values of one cell, and let's think about them like two states. Someone is mentioning, well, is alive or is dead? What happened to move from one to the other? I didn't put that here, but you're going to notice in the web page that you have here another stop. And if you think about start and stop and other options that are in the graphical user interface, you can figure out that, well, this is finally a state also, not for the cell, but for the full system. It's like the system is running. You'd like the example with the class is running, is new, is a stop, can continue. Everyone is dead, so we are in the end of the simulation. States. With a state, you explain the status of the game. With activity, the rules, and with the use cases, the big picture, the things that you need to do. Questions? Good? Okay. Homework. Can you complete this scenario? I didn't do the use case. I just put some examples here. I didn't create the activity diagrams. I just described the rules. Similar idea with the state diagram. Can you go to the web page? You can play a little bit with the game so you get the idea. And can you explain this? This is in the web page also. This is the info for the web page. Can you explain the game as a combination of use case diagram, activity diagram, and state diagram? Just for practice. I am not asking you to submit anything yet. This is not homework, not yet. My request for you guys, you do not need to submit. Practice. Use this to test yourselves, to check that you understand those three diagrams, how to use it, when to use it. And if you have a question, and hopefully you are going to have during the week, please do not hesitate to ask. Good? Any question? Okay, I am going to stop here. See you next week. No homework, just practice. Thank you.